Welcome to the Fall 2019 Midterm Review for E115. Your midterm will give you snippets of code like this, and based off this code, or codes like this, you'll be answering questions, whether that's answering the output, or writing code that works, or rewriting code. The nature of the midterm is going to be like that. So we'll get started with the review. Here's the first snippet of code. We have x equals 3, and then we have an if-else statement. When you run the above, what gets printed on the screen? So what actually gets printed on the screen is the value of x is 5. And the reason why is that if you look in the if statement, we only have one equal sign over here. We know that using proper conditional statements would use two equal signs. So right now, it's checking if x equals 5, and it's going to give me a true or false. But as it was originally, it's assigning the value 5 to x. So that's not returning a true or false. The if statement gets confused, so it'll output this when it's not supposed to. Okay, so let's write that down. X equals 5 assigns the value of x of 5 to x instead of checking if the statement x is equal to 5 is true. Okay, so if you do x equals 5 like so, well, let's see what happens. We know x is 3, so this is false, so we get to our else statement. Like so. Okay, here's our next snippet. We have int var, the user enters something for var, and then we have this if-else statements. What does this program do? This program takes in an integer from the user, and whether it's even or odd, the program will respond accordingly. Numbers if even, number if odd. That's a typo, it should be number is, like that. So ask the user for an integer and tells the user if it's even or odd. Why does it work? Because we're using the modulo operator. Using the modulo operator with 2, which returns the remainder of a division by 2. It makes a test case to see if it's 0, signifying that it's even, and then uses that for the if, or rather for the proper output. So anything like this, just explaining what's going on. We know that this is the modulo operator. It's the percent sign, and what happens is you take the value of var, you divide by 2, and it will return the remainder of that. So let's say if var is 5, what's going to happen? 5 divided by 2, we know is 2 remainder 2, 2 remainder 1, and this will get returned. If var is 5, this is false, so number is odd. If var is 6, our answer is going to be 3 remainder 0. So with an even number, if you divide by 2, you get no remainder, and that's why we have this condition here for number is even. Okay. So let's set this back to its original. So we have x equals 3, y equals 4, we have an if, nested statements, and then an else. Okay. When this code is executed with x equals 3 and y equals 4, what prints on screen? Well, x is indeed 3 and y is indeed 4, so what gets printed is the first print statement. Now what happens if x is 3 and y is 5? So let's change this. This first if statement is still true, so we go in here. But this if statement is not true, so we go to the else, and so the second print statement gets printed. If x is 10 and y is 4, what gets printed? So let's check this first. 10 does not equal 3, so this is false, and so we jump right to this else statement, like so. How about x equals 100? Same thing. This fails, And so we go to the third print statement. Okay, for our next snippet, we have again var. Let's start with 1 because that's what the first question is asking. If we run the program with var equals 1, what gets printed? Well, var equals 1. 1 is not less than 0, so this does not get printed. 1 does not equal 0, so this does not get printed. So we go to our else statement, and so the third print statement gets printed. Now if we set var to -5, like so, we'll go through this top to bottom again. Var is less than 0, -5 is less than 0, so we do this. And that's it, the first print statement. What value should be assigned to var if you wanted the second print statement to print? Well, we want this to be true, so all we have to do is set var equal to 0. Like so. Let's go to our next one. Haha, little hint over there. So we have this snippet of code, count equals 0, while count is less than 10, cout. How many times will this snippet print? This will print an infinite number of times, logically. And if you just look at how it is, you know, assuming that my computer will run forever, the US power grid stays up, things like that. What does the loop never end? It's because this condition will always be true, right? Right now count is 0, and nowhere else in this snippet of code does count change value. So count will always be 0, and 0 will always be less than 10. So count will always be less than 10, and so that's why it never ends. Count is always 0, so count less than 10 will always be true, and nothing is changing that. Something like that would be an acceptable answer. What do we need to change, and where to remedy this? Okay, so ideally you'd want to do it inside the while loop. And you can do anything that would change the value of count so that this conditional is no longer true. So you can just outright do something like count equals 22. And so 22 is greater than 10, so this is false and it breaks. You can do that, or you can start incrementing, and it'll get there soon enough. Okay. So we'll add count plus plus like so. And let's just check if we're still recording. Yes, we are. Consider the following while loop that is purposed to print numbers from 10 to 1, identify what's wrong and fix it. Okay, so here's an example where you have to rewrite the code. It's similar to what we've seen. So first we say count has a value, but then inside the while loop, you're not changing the value of count, so it's always going to be 10, and it's going to be an infinite loop. A simple remedy to this is to do count minus minus, even right in there. What happens is that first it will cout, and then it will decrement. If you do something like this, first it will decrement, then it will cout. So this will output 987654321. This will output 109876543221. Okay, here's our next snippet, var equals 2, and then we have a switch case. If we run this program at var equals 2, what gets printed? What gets printed is could not find a suitable case, because var doesn't equal 1, and var doesn't equal 3, so our default is this. How do we change the above code to print in case 2? There's two ways of doing it. You can either add a new case for 2, like so. Or you can be pretty cheeky and just change one of them so that 2 is covered. Either way should be correct. And if you get points taken off for this, well, I would find a reason to argue in favor for you. But to be I guess not as avant-garde. We'll say that. Okay. Okay. So this is a for loop. How many times does inside the for loop print on screen? So we have from int I equals 0, I is less than 10, I equals I plus 2. This will print 5 times. Why? Because this prints for I equals 0, 2, 4, 6, 8. So you're adding 2 to I after every loop, which is fine. It's a valid mathematical expression, so it's okay for this increment spot. And so you start off as 0, 0 is less than 10, good, and then you count up by 2. So 5 numbers. What do we do to change it and make it print the statement 10 times? There's 2 ways you can do this. Let me just copy the for loop. You can either do I equals I plus 1. Instead of adding 2, you're adding 1. Conversely, or I guess the other way, instead of making 10 the upper limit, you make 20 the upper limit. So you're just going to count up the even numbers from 0 to 18, and I think that should be 10 times. Here's one of those curveball questions. What statement gets you out of the program, gets you out of the whole program? Break or exit? Exit gets you out of the program. Break gets you out of the current loop slash layer of code. Okay? And if ever you come across something like this and you don't know, you can always copy that snippet of code or, go to a new file and just test it, write a simple file and run it. This is something I just made to see what would happen with break. So because you have this resource, if it's useful, go ahead and use it. Okay, convert the following while loop to a for loop, where you're going with count starting at 0 and it's less than, it'll keep going while it's less than 10 and it increments by 1. So we're going to go for int count equals 0, count less than 10, count plus plus, cout hello world. The \n is also a line break, so that does the same thing as end L over here. So you can do this. You can name this I. I mean, it's doing the same job. Different name, same job. So that's fine as is. Convert the following if-else block to a switch statement. Okay. So first we'll start off with int var equals 3. Let's give ourselves some space so that we're not distracted. We'll start off by switch. Give myself the squiggly brackets. Then I would say var. So switch parentheses, and inside the parentheses is going to be the variable that you're testing. And so in here, the equivalent of if var equals 1 is going to be case 1, like that. We do our cout statement. It's 1. Then after each case, you break. Okay, case 2. This is going to be for the else if var equals 2. Like so. And the else is going to be default. Neither 1 nor 2. Like so. Okay, so here we have 2 blocks of code. Block 1, block 2. Block 2 is missing the squiggly brackets. What's the difference about block 1 and block 2? Well, firstly, there's the squiggly brackets. But also, the outputs will be different. So the implication is that the outputs will be different. So what will block 1 and block 2 print? This is block 1. Var has the value of 10. It checks if var equals 5. It's not, so this doesn't run. So block 1, nothing. Block 2, so var equals 10. We're checking if var equals 5. It doesn't. So what happens actually is that, and this is the second line gets printed. If something like, an if statement or a loop, which we normally do write them with squiggly brackets, if they don't have a squiggly bracket, that means that they're holding just the first line immediately below it. Okay? It's one way that the C++ typing goes to make it look a little neater. So instead of having to do something like this, where you dedicate an extra line for just one line of code, you can just clean it up and do it like that. Okay, so the only thing that's included in this if statement is this line, var is 5. And so it behaves like this. Consider the void functions, or the following void function that adds 2 and then doubles it. So that's what this function does. It adds 2 and then it doubles it. Then it prints out the result. We want to return the result. So we're going to modify this function. Because we want to return the result, I'm going to see what kind of data type x is. X is an int. So our function is going to be of type int. Int process this int x. The math, the stuff in the middle behind it, is going to be the same. X equals x plus 2. You can write it like this. It's the same. Similarly, this does the same math. X equals x times 2. And we're returning the value. We don't have to see out it. So just return x. There you have it. I've added a little extra tidbit over here, courtesy of Dov Kruger in the EE 552 C++ course. I think it's 552 or 553. It's just a bunch of loop drills, and we'll go over it. And if we know how to do this, we should be a-okay with anything with loops. Okay, so all we gotta do is tell what each thing outputs. So for int I equals 2, I is less than 15, I plus equals 2, so you're adding 2 to I. The output would be just 2, 4, 6, 8, 10, 12, 14. Okay? Notice there's no spaces between the numbers because we're not including a space in the cout statement. For the next loop, I equals 0. For I is not equal to 0, I plus plus. This has no output because at the beginning we set I equals to 0. This for loop will only run if I doesn't equal 0. Well, this is false from the beginning, so there's no output. Okay, for short int equals 5, I is less than 8, I plus plus. Oops, this should be I minus minus. Okay, so we decrement. We know 5 is less than 8, so we'll just keep going. 5, 4, 3, 2, 1, 0, negative 1, and so forth. For E115, well, first, since we didn't go over short, if I did something like this, I would leave it at that, and you'll just keep going down the negatives. And logically, if we forget about the value limits of int, this will just keep going on forever, counting negative, right? But I'm going to keep it as it's intended. The range of short int, the lowest number it can hold is this, so that'll be the lowest number over here, 3, 2, 7, 6, 8. And what happens is if you subtract 1 from this, it will underflow and kind of loop all the way to the top, the highest value that short int can hold. And so, well, 32,767 is not less than 8, and so this will be the last number we'll see in this loop. Okay, our fourth loop, int I equals 1, I is less than 100, I times equals 2. So we're starting off with 1, and we're just going to keep multiplying it by 2. 1, 2, 4, 8, 16, 32, 64. We're not printing 128 because this loop will only run while I is less than 100, so that's all we got. Okay, last loop. Int I equals 100, I is greater than 0, I equals I divided by 3 plus 1. It's a little mouthful, so we'll go through this one number at a time. 100 is greater than 0, so 100. So 100 divided by 3. Now remember, it's int mats, so if we have a decimal in our result, we're chopping it off. We're rounding down. So 100 divided by 3 is 33.3, so it'll be 33 plus 1, 34. 34 divided by 3 is 11 something, so it's going to be 11 plus 1 is 12. 12 divided by 3 is 4, plus 1 is 5. 5 divided by 3 is 1 point something, so it's going to be 1, plus 1 is 2. 2 divided by 3 is 0, plus 1 is 1. 1 divided by 3 is 0, plus 1 is 1. 1 divided by 3 is 0, plus 1 is 1. And so we already see it's just going to keep going to 1, and so this will be an infinite loop. Okay, so that's all I have for the midterm. One thing that I noticed was not in here was string concatenation. Real quick, let's say if I have string first, like so, and string last like so. String concatenation is this. You're taking two smaller strings and combining them so that they become one bigger string. Okay? This is string concatenation because this will behave as if it's one big string. Okay? This is not string concatenation because that's the same thing as saying that. You just happen to be outputting first and last in the order you want it to, so that it looks like one string, but in technicality, it's not. So please, 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 for string concatenation, use a plus sign. Okay? That should be it. Good luck with your midterm. There is no lecture on the Friday of the midterm, and there's no recitation the week following the midterm because the TAs will be grading. So, once again, good luck.